Hello everyone, my name is Khaja Mohiuddin Syed and today I will be presenting on Apache Hadoop for Scalable Data Lake Architectures. In this presentation, we will explore how Hadoop technologies support the architecture of modern data lakes, making them scalable, flexible, and suitable for big data applications. So here is a quick look at the agenda for this presentation. We will cover the various layers of a Hadoop-based data lake architecture. Starting from the data injections, we will go through storage, resource management, data processing, orchestration, governance, security, and monitoring. Each layer plays a crucial role in building a robust and scalable data lake. Here is the full architecture overview. We will get the explanations in detail for each and everything. So moving ahead. What is data lake? A data lake is a central repository that lets you store structured and unstructured data at scale. Unlike traditional databases, you don't need to define a schema before storing data. You can analyze data in its raw form using dashboards, big data tools, real-time systems, or even machine learning. Key features include schema on read, scalability, low cost storage, and flexibility. Key concepts in data lake architectures. There are some core principles of a data lake. Raw data is stored in its native format. Structure or schema is applied when the data is accessed. This is called schema on read. Compute and storage are decoupled, meaning they scale separately. Supports both batch and real-time streaming data. Compatible with multiple analytics engines, SQL, NoSQL, ML, etc. Governance and security are built in with features like metadata tracking and role-based access. What are the components of data injection layers? The data injection layer is where data enters the lake. Key tools here are Apache Flumes, which collects streaming data like logs or social media feeds. Apache Sqoop, which imports data from a relational database like MySQL or Oracle. The data is ingested into systems like HDFS, Hive, or HBase. This slide shows how Flumes and Sqoop feed data into the systems. Flumes is good for real-time events and Sqoop is used for bulk transfer from traditional databases. The ingested data is sent to storage components like HDFS for further processing. We will talk about now data storage layer. So moving ahead, components of the data storage layers are: once data is ingested, it need to be stored. The two key storage systems here are HDFS, which is Hadoop distributed file system used to store data and process data. HBase, a NoSQL database for fast read or write access. It's built on top HDFS and is useful for applications needing real-time lookups. How it works, I've told you. So here is the architecture storage layer. Like this slide shows how data moves from injection to storage. HDFS stores everything and HBase allow fast data access using region servers coordinated by a central H master. Resource management layer handles how computing resources are allocated. Hadoop use yarn at another resource negotiator. For this, the resource manager receives job request and allocates resources. Each node has a node manager that monitors tasks. This ensures job runs in parallel and are fault tolerant. The components of resource management layers are yarn and node manager. Like how it works, it's like a parallel. So this layer is where a data processing layer is where data is transformed and analyzed. Key tools include MapReduce for batch processing, Spark for fast in-memory processing, ideal for machine learning and streaming, Hive for writing SQL like queries on big data, PIG, which is a scripting language for data pipelines. These tools make it easier for extract insights from raw data. So here is the data processing and analytics layer. Moving to the workflow orchestration layer, this layer manages the scheduling and executions of data workflow. Apache Oozie is used to schedule jobs like MapReduce, Hive, and PIG. Apache Falcon helps with lifecycle management, handling replication, data movement, and retention. Together, they keep data pipeline running smoothly and automatically. So here is the workflow of the orchestration layer also. So how it works. Now moving to the metadata governance layer. In this layer ensures we have control and visibility over data. H catalog shares metadata like schema across tools like Hive and PIG. Falcon helps define policies for compliance, data retention, and lineage. This supports auditing, traceability, and governance. Here is the diagram. So metadata and governance layer. Moving to the security and access layer. Security is crucial in any data architecture. This layer includes Apache Ranger, which enforce access policies at a fine grain level. Kerberos, a network authentication protocol. Knox, a gateway that provides secure access to Hadoop ecosystems. These tools work together to ensure only authorized users can access specific data. Over here is the clear flow diagram of security and access layer. And last, like monitoring and admin layer. So monitoring tool helps us track the health and performance of the system. Ambari is used for monitoring, provisioning, and managing Hadoop services. ZooKeeper coordinates a task among distributed systems. Um, Grafana and Prometheus provides visual dashboards and alerts for metrics. These tools make it easier to manage a large and complex data lake infrastructure. So here is like flow. And thank you for watching this presentation. I hope this gave you a clear overview of how Apache Hadoop supports scalable data lake architectures.